I got a little overzealous with my work for that last one, but let's try this one now. So we've looked at some different period changes, but let's look at a phase shift for this one. All right. So again, my amplitude for this one, still just a 1, so we're just hanging out there. Am I vertical shifting at all? Nope, not this time. What about my period? No, but I am doing horizontal, right? My period is in front of the x, but I don't have anything in front of the x, so my period is still just the general 2 pi. Good. Oops. Because that's what it is for sine. But what is happening? Phase shift. Now, remember, everything that is horizontal is opposite of what you think. So which way am I shifting this one? To the right or to the left? To the right. Good job, guys. Because it's negative, so it's opposite of what you think. So I'm going to go to the right, pi over 3. Okay, good for you. Now, when I'm looking at shifting this, the best way to look at this is say, okay, I'm going from 0 to 2 pi. And I'm going to take that and I say x minus pi over 3 goes between 0 and 2 pi. So I have to figure out, if I'm making this shift, what are my my beginning and my end values going to be? All right, so I'm going to add pi over 3 to both sides. Pardon me. I'm going to scoot this up a little bit. And I now have pi over 3 is where we're starting, which is less than or equal to x, which is less than or equal to, if I add these together, I get a common denominator. So I end up with 7 pi over 3. So my initial value here is going to be at pi over 3. My ending value is going to be at 7 pi's over 3. All right. Now, to get to the middle, I have to add that up and divide by 2. So I'm expecting you to do a little bit of head work here. So I've got my this value, and this value we're trying to find. So to get to this middle, to get to this middle part, I have to add these up. 1 pi over 3 plus 7 pi over 3 is 8 pi's over 3. Divided by 2 will be, I'm going to get a different color to reduce this fraction. 4 pi over 3. Do you see that? Because you just reduce the fraction. 2 goes into 8, so we get 4 pi over 3. Then I'm going to come over here to the other side, and I've got 4 pi's over 3. So add these up. 4 pi's over 3 plus 1 pi over 3 would be 5 pi's over 3. So add those two together to get 5 pi's over 3 times that 1/2, and nothing reduces there. So I just end up with 5 pi over 6. And so it's always just that middle part. So you find the middle, then you find the middle of each one of those. To get from here to here, now I have 7 plus 4 would be 11 pi's over 3 times 1/2. Again, nothing's going to simplify there. So I get 11 pi over 6. So those are the different values that we're looking for. All right. Now, I'm not doing any stretching here at all, so no amplitude change. Let me go red. I think you'll be able to see that better. Or blue, potentially. If I have this as a 1, this is still down here at -1. This is sine, so we know we're quote-unquote starting at 0. But if I make this a pi over 3 here that we have, and then I'm looking at this as 2 pi's over 3, 3 pi's over 3, which is just pi, 4 pi's over 3, 5 pi over 3, 6 pi over 3, which is 2 pi, and then there is that 7 pi over 3, right? So we've just taken this, and you can see how I'm shifting over, and I'm starting at pi over 3, and I'm ending at 1 pi over 3 past that 2 pi. Now here's the kicker. Whenever I'm looking at this problem, I have, because I'm putting this in terms of pi over 3, I have 5 pi's over 6. So where is 5 pi over 6? Right? So this is technically 1 pi over 6, 2, 3, 4, 5 pi's over 6, which makes sense because it's just barely under 6 pi's over 6, right? So here is my 5 pi over 6. The same thing that's happening over here with 11 pi over 6. It's just one shy here. That's 11 pi over 6. It's just one shy of that 2 pi. So if I'm hitting my marks, it's sine, so I'm starting at 0. I am at the top at 5 pi over 6. I'm back to the center here at 0. That looks off, doesn't it? I'm coming back down here and then back up. Oh, you guys are probably all hollering at me. So I'm looking at this going, man, that looks off. Well, it looks off because I'm starting at pi over 3, not 0, y'all. Oh, for crying out loud, right? You guys are probably all hollering at me going, you're starting at pi over 3. This is why I love having you guys in class, because you keep me on it. That's so good. Okay, so here is our graph then, right? So I'm going to go up, down, and then hit this. So there is our sine curve. Shifted that pi over 3. So the key to this one, and we all know that this keeps going. This keeps going, right? It's just, we're just graphing that 1 pi. Okay, or 1 period, sorry. We're graphing the 1 period. All right. The kicker to this, and what makes this quote unquote more difficult, or whatever you want to say, is if you have the problems that deal with any type of horizontal transformations. If you're changing your period, then you have to do work on that. If you do any kind of shifting, then you have to adjust, because that's not where the normal, quote unquote, normal ones happen. And you just work with it. Okay, I want to do a couple more with sine and cosine to really get those transformations. We're not going to get hardly into our other 6 trig functions. We're just going to get the basics of those. I really want you, most everything that we deal with, except for tangent, deals in terms of sine and cosine. So that's why I'm really hitting these hard. So I would like to do a few more examples of these. Make sure that we're really good with all these different kinds of transformations, especially since we haven't gotten into them big time yet. So let's do a couple more with higher transformations, and then we'll talk about our other trig functions, which is super exciting. So let's look here at example 6. I have y is equal to 3 minus 2 cosine of 3x. Now we got some good stuff. Check it out, you guys. This is super exciting. Okay, what about my amplitude? It is the number in front. Good, but what else do you notice is happening with this amplitude? Yes, my amplitude, I'm going to write -2, but we know that this negative sign there means that reflection. Because this is cosine, and cosine typically starts up at +1, what does that mean now? It's going to start down. Good. So for cosine, I'm starting down and then going up, where normally we start up and go down. Okay, good. Now, do I have a vertical shift? Oh, we certainly do. I'm going to go up 3 on this. All right. Am I changing up my period? Yeah, because there's that b value. So this will be 2 pi and divide it by that 3. So my period is really 2 pi over 3. Now, am I a phase shift on this particular one? No. So there aren't any phase shifts. The only horizontal is just changing that period. Okay, so let's come up with these values. I know that I'm going to move up 3. So on my graph, I'm going to take this up to 3. I'm going to put this dashed line in here because when you do that vertical shift, you're basically changing that horizontal axis to be up to that value. So we're just going to be working off of that one. Now my real question is, what's going to end up happening here? I know I'm reflecting and with a amplitude of 2, so it's going to go out farther. But with my period, I start at 0, something, 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 and I end at 2 pi over 3. So half of that would be 2 pi over 3 times 1/2, because 0 plus anything, right? So that's going to put me at pi over 3. Let me make that pi a little bit nicer. All right. Then half of that, 0 plus pi over 3 divided by 2, would be pi over 6. And then over here, I have pi over 3 plus 2 pi's over 3 would end up giving me 3 pi's over 3. So the 3's go, and I end up with pi over 2, right? Okay, so let's do this thing. I'm starting here at pi over 6. 2 pi's over 6 is the same thing as pi over 3. 3 pi's over 6 is pi over 2. 4 pi's over 6 is 2 pi over 3 when I reduce that. Now here's the kicker. I have an amplitude of 2. So if this is my 3 and I'm going by ones here, I know that I am going to start down here, 2 down. And I'm starting down because, oh, for crying out loud, I did it again. Oops. This one starts here at 0. And then at pi over 6 is where I then cross that axis, right? Pi over 3 is when I max out. Pi over 2 is when I cross that shifted up axis again. And then I'm at 2 pi over 3. So my graph is going to look like that. Now I know this goes on and I know this goes on. Right? Does that make sense? Okay. Now notice what's happening. When this goes on, am I taking it down here? No. This comes back up to start another period. This comes back up to start another period. If you put an arrow down going this way, then you don't know anything about the function. I want a good working knowledge of this function. This is periodic. So I could take this back over here, come back up, and then keep going down, right? That's the whole point of this. I'm just simply looking for this one period just so that you have that basic idea. But the thing is I want to make sure you know this does go on forever. It is that periodic function. I'm only looking at one of those periods. All right, let's do one more and then we'll move on to our other trig functions. But this is fun, right? It's cool to look at all this stuff, I think. So here's example 7. Y is now equal to a -1 plus 2 sine of 4x plus pi. Ooh, literally everything that can change does. Now, I want to point something out to you here real quick. When you have not only a phase shift, but you also have this working with your period, I'm going to bring you back up here to this. Look at what happened with our transformations. This B value is factored out. That's how you get your actual B value. You have to get that factored out. So if I'm looking down here at this one, I need to look at this in the factored form. So y is equal to -1 plus 2 sine of, if I factor out that 4, I get x plus pi over 4. And the 4 is my B value here. And then I have my phase shift. Do you see that? Okay. So you have your phase shift. That's once it's already factored out, that is when you get your phase shift. So because let's just go straight to that because we're already talking about it. If this is plus pi over 4, how am I moving? Left, pi over 4. Good. My period is affected now. I have 2 pi divided by 4. So my period is actually just going to be pi over 2. And then my vertical shift, down 1, good, because that's this number out in front. Do I have an amplitude? Yeah, I do. It's 2. Literally everything that can change does. How exciting is that? All right, cool. So with my vertical shift, I like to go ahead and put in an imaginary line there. I'm just going to go down 1 with that, but know that I'm coming up here to 1 because this is an amplitude of 2 and down here to a negative 3. So keep that in mind. All right. With my period, I'm scoot this up. With my period here of pi over 2, and I'm shifting to the left, pi over 4, look at how all of this plays out. So I have 0 is less than or equal to 4 times x plus pi over 4, which is less than or equal to 2 pi. Now, if you divide both of those by 4, because 0 divided by anything is still just 0, and I have pi over 2. A lot of times I just skip this step because I'm going from 0 to pi over 2, right? And x plus pi over 4 is how I'm shifting my new period. But however you want to write that, that's up to you. Then minus pi over 4, minus pi over 4, minus pi over 4. So I'm going from negative pi over 4, which is less than or equal to x, if I get that common denominator. So I'm going from negative pi over 4 to positive pi over 4. So I have negative pi over 4, something, 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 and positive pi over 4. Now this one's super awesome, right? How cool is this? If I'm going from negative pi over 4 to positive pi over 4, what's in between those two? If I add those up, negative pi over 4 plus positive pi over 4, you get 0, right? Yes. Then I'm going to take negative pi over 4 divided by 2. Oops, negative pi over 4. My head went faster than my hand. Divided by 2 is going to be this negative pi over 8. Same thing's happening over here with positive pi over 8. It's pretty sweet, right? So I'm at this mark, and I'm going to come up here to, you can make it to pi over 4, negative pi over 4, and I'm starting, let's go back to this. Here, I'm going up to this value, hitting that, down here, and then back up. There's my actual graph. As we know, this does just keep going. This does just keep going. I want to just really emphasize the fact that we're only graphing one period, but that doesn't mean my graph stops there, right? Okay. It doesn't matter how many